Example 4 is all about the algebra. All about the algebra. How can we best simplify these and get them to the point where we can actually take the derivative? So each of these we want to get it to the point where it's a constant times x raised to a power. If we write it as a constant times x raised to a power, then we can apply a combination of the power rule and the constant multiple rule, and we can find these derivatives. First one, in fact, I'm tempted just to do the algebra with each one first and then come back and find the derivatives, just so the point is writing each one as a constant times x to a power. The first one is 7/4 times x to the negative 3. Y equals that. Not dy dx, of course. No derivative yet. But just y equals 7/4 times x to the negative 3. Then we're in a position at this point to take the derivative. The next one, y equals, well, the 4x is cubed, so we've got to go ahead and clear the parentheses. 7/64x cubed. So a little bit different, but not too much different. Y equals 7/64 x to the negative 3. Then we can take the derivative of that. The c part is actually quite nice because we have the negative exponent starting out in the denominator. In this case, y equals 7/4 times x to the positive 3. And we can take the derivative of that. And the d part, y equals 7 times 4x quantity cubed. Now what that means, the entire quantity 4x is raised to the negative 3, so that means the entire quantity 4x should be shifted up to the numerator, and I should change it to positive 3. Then we cube it, and y equals 7 times 64x cubed, and let's see, 420 plus 28, 448. So y equals 448 x cubed, and then we can take the derivative of that.
Why didn't we just pull the x out like we did for the rest?
For this d part, because of the parentheses, and because we had a negative exponent on the parentheses, I suppose I could have worked in the denominator first. I could have said 64x to the, well, I would have had to say 4 to the negative 3 down in the denominator, and it would have been 1/64. 1/64 x to the negative 3 down the denominator, and I was just a little uncomfortable with that. So rather than having to deal with the complex fraction, I just went ahead and took the whole thing up to the numerator, and it made it quite nice because it made the exponent positive once you moved it up to the numerator. And then, how do you feel about those derivatives at this point? Do a little bit of algebra. It shouldn't be too bad. Let me see if I can do it. Dy dx equals negative 21/4 x to the negative 4. So I guess there is a little something to this, because then I want to write it as negative 21 over 4x to the 4th. So there's the task of taking the derivative and then cleaning it up a little bit and expressing it with a non-negative exponent. So final answer to that part, dy dx equals 21, very similar here, 21/64 x to the negative 4. So dy dx equals, whoops, I left off the negative, didn't I? So sorry. Negative 21/64 x to the negative 4. So negative 21 over 64 x to the 4th. Dy dx equals 21/4 x to the second power. Subtract 1 from the 3 to get 2. Not too much more simplifying to do there. And the last one, dy dx, if I can multiply 3 by 448, I don't think I can. 14? 1344 x squared. Parentheses, negative exponents, where they're positioned in the denominator, can be tricky. So make sure you simplify it, clear the parentheses if necessary, and write it as a number times x to a power. And then you can apply a combination of the power rule and the constant multiple rule.